In this video, I'm going to go over a horizontally launched projectile problem and walk you through it step by step, and then you're going to use these tools to solve the problems on your station. So this problem, a student was standing at the top of the bleachers 3 meters high. I'm going to stop right there and I'm going to draw this picture. It doesn't have to be anything beautiful. Here's my bleacher. Here's my person standing. And they're going to throw a ball. Alright, so we'll make the ball red. And he's throwing it horizontally, so I'm going to show it like that. And it landed 40 meters away. Okay, let me add a few more things in here. So he said that it was 3 meters high and that it's landing 40 meters away. Let's say that's 40 meters. This is obviously not drawn to scale. There we go. What was the initial horizontal velocity of the ball? So basically, it's wanting to know how fast did this person throw this ball to make it go 40 meters away, which is pretty far. So our initial velocity in the x direction is what we're looking for. So the first thing in a horizontally launched projectile problem, when it's thrown, kicked, tossed, pushed, whatever, we need to make an XY chart. Now, I teach this a little differently than some other teachers, so we're just going to kind of talk through this. First thing I want to put down is my distances if we know them. So this 3 meter is the distance in the y direction. So I'm going to pop over here to the y, and I'm going to put dy equals 3 meters. Now it's actually negative 3 meters because the ball is going down. My dx is this number right here. So I'm going to put dx equals 40 meters. Now it's positive because it's moving to the right, and that's the positive direction. Now, according to the last video, if you watched it, we talked about acceleration. Acceleration in the x direction doesn't exist. It's 0. There is nothing that is causing this object to go faster or slower in the x direction. Therefore, the acceleration is 0, which means my initial velocity is my final velocity in the x direction. Speaking of which, the vi in the x direction is what I'm looking for, so that's my unknown. Now my y direction. Acceleration is gravity. So you can write ay, you could write g there, whatever it is that makes your heart happy. And it's actually negative 9.8 meters per second squared because it's speeding up and going down. Now my vi in the y direction is 0. It's not dropping closer to the earth until it actually starts moving. So the initial velocity in the y direction is 0. And we don't know final either, but it's irrelevant to solving this. You have to remember that time is the only thing that overlaps both of these. So I like to put time down here at the bottom. It is the key thing. If what you're looking for is VIX and you don't have enough information to solve for it, then you're going to have to solve for time first. So the equation that you use on these problems, I'm going to give you kind of the long equation and we're going to break it down. It's this equation off your formula chart. That's a t, VIT plus 1/2 AT squared. Now you use the same equation for both sides, but I'm going to show you what happens. So this right here, I'm switching to my highlighter. Because my acceleration is 0 in the x direction, when I use this equation, this whole part right here, because a is 0, gets canceled out. So when I'm using this, when I'm trying to solve this in the x, all I use is d equals vi times t. And that's my equation for the x side. So if I'm using anything on the x side, I'm going to use d equals vit, because I know acceleration in the x direction is 0, so this whole thing's going to cancel out. Now in the y direction, that looks a little bit different. So let me rewrite this really quickly. In the y direction, it's not your acceleration that is 0, it is your initial velocity. that's 0. So if I were to plug this in for my VI right here, it'd be 0 times t, which 0 times any number is 0, so this cancels out. So in the y direction, the equation that you would use is d equals 1/2 at squared. Now, there are some teachers that teach it a little bit differently than me, as I've said before. So I'm going to see if I can recreate what they do, so those that are watching it. On the x side, you might have just had, I think, delta x equals velocity times time. It's the exact same thing as d. I just like to put dx. Over here, instead of d, you would have delta y equals 1/2 at squared. Again, exactly the same thing, it's just written a little bit differently. Now, using these equations, we are going to solve this problem. I'm going to clean it up just a little bit here. Alright, so in order to solve for my VI in the x direction, which is what I'm looking for, it's what the problem is asking, initial horizontal velocity, I have to have VI, or not have VI, but it needs to be in my equation. And in order to solve for VI, I need to have d in the x direction, and I need to have time. I have d in the x direction, it's 40, but I don't have time. That means I'm not ready to use this equation. So that means I have to bounce over to the y side. And I have to take this equation, d equals 1/2 at squared, and I need to get time, because time is what I'm missing on this side in order to solve for it. So my distance in the y direction was -3. It's still 1/2 times a negative 9.8 times t squared. So I'm going to simplify. I'm going to leave my -3 alone. I'm going to plug in 1/2 times negative 9.8 into the calculator, and I get -4.9. I still have my t squared. I'm going to divide both sides by -4.9. Do not add 4.9 to both sides. It's being multiplied by t, so you have to divide. When you do that, you get that t squared equals 0.612 seconds. Now I need to take the square root of that, and it's getting messy now, but my t equals 0.78 seconds. So that's how long this ball was in the air when this person threw it 40 meters. This person is like a superhero person in order to throw 40 meters in less than a second. Now, we have our time. And remember, time is the same on the x and y side. So let me recap really quickly. When we started this, we were looking for VI in the x direction. In order to use this equation to solve for VI, I need d and I need t. I have d, it's 40 meters, but I don't have t. So that meant I have to hop over here and solve for t. So I plugged in -3 to my problem. I plugged in -9.8 for my acceleration, and I solved algebraically for time, and I got 0.78. You're not done, because we haven't officially solved the initial horizontal velocity. So now you have to take this time, and you have to plug it into this equation on the x side. So I'm going to work right on this picture now. I'm going to take this equation. D in the x direction is equal to the initial velocity in the x direction times time. My d was 40 meters. It is positive because it's moving to the right, equals my VI is what I'm looking for, times my time, which is 0.78. So we're going to divide both sides by 0.78. And we get that VI equals 51 meters per second. That would be your final answer, and you would be done solving this problem.